So I'm going to talk, thanks Lloyd for having me out here, and thanks to the board for putting this on. We've spent a fair bit of time over the last few years talking with the folks at Transwest Express, with Bill Boyd and Bill Miller and the rest of the crew, about kind of what we're doing, what they're going through. We try to compare notes with them regularly because this business of very long distance transmission lines to get renewable energy to market it's kind of a new industry that is solving an interesting problems, and we always find it really helpful to compare notes with those folks. And so we're thrilled to come out and learn from what's going on in Wyoming. And it was great to come right after Catherine, because she sort of teed up nicely all the different things, all the different issues that we're working through as we try to permit these long distance transmission lines. But let me just tell you a little bit about what we're doing. So my background is in the wind business, and I spent in wind years. I qualify as an old dog because I've been doing it for like 15 years, and helped start a company called Horizon Wind, which is now probably the third largest player in the industry. It went through several different family ownership and then on and on. And I left that in the late 2000s, and after a second place finish in a political race, I decided to go back to something I actually knew something about, which is energy development. And it felt to us and to my colleagues from Horizon, who kind of came over to help start the company, that transmission is the biggest, baddest problem out there. And if you really want to get a lot of new renewable projects built, then transmission is the way to do it. So this is what we do. This is basically all that we do, and we're trying to connect the wind in the central part of the country to places on the grid where you can inject several thousand megawatts of wind. So we don't do the wind development. There's a lot of folks who know how to do that. We only focus on the transmission piece of it, and we find that focus on just transmission, wind development is interesting enough, and transmission development is hard enough without layering the wind in on top of it. So we're really just focused on this one particular piece, and we do not believe it or not, we don't think that there's some magic solution that's going to emerge from congressional deliberations on transmission policy. We think that the way to do this is one step at a time. You piece together existing state authority and do it one step at a time. Just chip away at it, and we think that if you work long enough and hard enough at it, that we'll be able to either hobble together different state authorities to make our project happen, or where there are bits and pieces of federal authority, like I'll talk about in a minute, use those authority, or a combination of federal authority and state authority to make the projects happen. So sometimes it feels like we're running not a business, but a think tank, because there's so many interesting issues to tackle when you get into transmission development. But we are guided by the view, and this comes from our experience in wind, that wind is going to get cheaper and cheaper, and that capacity factors are going to go up. We often look to the Lazard. There's all kinds of different studies about what things cost. We find that the work that Lazard does is usually it's certainly the most accurate in terms of what's going on in the renewable space. We're more dialed into that than the other things, but this is their view of what's happening elsewhere. And obviously the natural gas numbers depend to a very large extent on what's your view of natural gas. I live in Houston, and there's, you can go to your kids' soccer games and go to the sidelines, and you'll have many different opinions on that topic. But we believe that because of the continued improvements in wind technology and the globalization in the supply chain, that the cost of wind is going to get lower and lower. and this has really been a surprise to us over the last 4 years since we started the company, you can put, for every $1 million that of money or capital that you put into a wind project versus 4 years ago, you're getting about 35% more energy from your $1 million investment. And that's just in the last 4 or 5 years. And we spent a decent amount of time with the turbine manufacturers, talking with them about sort of what kind of tricks do they have up their sleeve. And all of them say that there's still 15, 20% room for improvement still coming down the pike, still in the lab, but coming down the pike. What's driving that is the obvious issue of bigger machines. Energy capture is a function of swept area, and we all remember our high school geometry of pi r squared. So if you increase the length of the blade, you get a lot more swept area. The other big improvements are coming in terms of the control logics of the machines, which mean that the machines are pitching much more quickly. There's full span pitch when they're at different places in their rotational cycle. They're pitching at different angles. That also increases energy capture. Lighter blades, the use of carbon fiber in the blades means that you can use bigger blades. Lots of the manufacturers the next big wave seems to be the elimination of gearboxes with direct drive turbines. With that, you'll eliminate about half the moving parts. And the gearbox, because it's the piece of the machine that's subjected to the most stress, is always the Achilles heel in wind development. So to the extent that that's entirely eliminated, that can really do interesting things in terms of simplifying machines and increasing energy capture, because all that energy that goes into the gearbox and cooling it and so on is energy that doesn't get turned into electricity. So we're very excited about what's going on in wind. We did an RFI, our little request for information, in conjunction with one of our projects, the Plains and Eastern project, which I'll talk about in a second, but it originates in the Oklahoma Panhandle, to say, okay, come forth all ye wind developers, tell us how many megawatts you got under development, what are your prices, etc. And the price, the cheapest 4,000 megawatts that we got were in the sort of 2.5 cent range. The average of the 16 gigawatts that proposed to us was in like the 2.8-ish sort of range. So really exceptionally low prices. Now those are numbers with the production tax credit, okay? And so you always kind of wonder, okay, what would it cost? What would wind cost without the PTC? And at some point there won't be a PTC, so this is a pretty relevant question. I think the most interesting information on that topic is actually coming out of Brazil. And in Brazil, they have an interesting wind resource in northeast Brazil. They have a different policy mechanism. Basically what they do is there's a state-like authority which signs up for 20, 25-year contracts. You pre-qualify your projects, and then they do a declining clock auction. So they start off and they have 10,000 megawatts of pre-qualified projects, and they say, okay, who wants to sell us energy at 6 cents? And then everybody raises their hand, and then they say 5.5, and a few people drop out, and so on until the auction clears at the couple of thousand megawatts that they want to acquire. And those prices, and again, this is in Brazil, where you have some lower cost manufacturing, not as good logistics, higher project finance costs in terms of interest rates and so on. So those auctions are clearing in the low 4 cents. So that's an interesting indication of what would the U.S. wind industry look like if we didn't have a tax credit, okay? And that, I think, lines up. If you look at the tax credit, it's about 2 cents for 10 years. It's a post-tax item, which actually boosts the value of the PTC. But I think it's really interesting to look at the experiences elsewhere in the world and see how much wind costs when you have different sorts of policy support mechanisms. The disadvantage, obviously, of the PTC is it limits the universe of people that can invest in it. So for Wyoming's purposes, it's interesting that if we do end up in a world without a production tax credit, you're probably looking at production costs in the 4 cent range, okay? And I think it's most instructive to think about the cost of wind in terms of what's your avoided fuel costs, okay? And then we believe that there's capacity value in wind. Obviously it's not the nameplate capacity, but there is real capacity value, particularly when you have a geographically dispersed resource. But at its sort of most basic terms, I think everybody can agree that if you're running a wind turbine, you're burning less natural gas or less fossil fuel, or there's water behind the reservoir that you can hang on to and run through your dam some hours later. And so that's sort of, from a marginal cost perspective, low 4 cents is in the range of, $5 and something cent natural gas, which puts us in the hunt and really makes wind an interesting part of any energy portfolio. So if you got it, you really ought to think about the possibility of using it. So this is just a scattergram of what wind has cost over the years. The low costs in the early 2000s, those were due to a pretty weak dollar and, a weak euro? Yes, a weak euro, which meant that the cost of the equipment was really low. We were working on pretty much exclusively on DC lines. We have a project in New Mexico that we picked up recently, which is an AC line. It's sort of a collector system that another developer has been working on for a few years, but we're really focusing quite hard on DC. You guys know from the projects under development in Wyoming the benefits of HVDC lines, but I'll just kind of go through them. In terms of control of power flow, you get much better control there. That's important because for perhaps a non-obvious reason. If you're talking about the integration of large volumes of wind, it's difficult for a state, which is basically an export state like Wyoming, to integrate all that wind. So to the extent that you can deliver the variability to the injection point in Nevada or wherever, that grid also has some variable resources, but their variability is totally different from the variability in Wyoming. And we're also working on projects in New Mexico, which would deliver energy to California. The resources in New Mexico and Wyoming do not correlate at all, and in fact are quite complementary. And DC lines are particularly good at sort of taking the variability from Wyoming and injecting it into Nevada. And that helps on the overall cost of reducing the cost of integration. DC lines are lower line losses, so they're more efficient, and you need less right-of-way to transport a similar amount of energy. This is, let me just focus. So again, we're working on a number of projects, but I thought it would be most interesting if I focused my remarks on this project called Plains and Eastern, which is similar to some of the things going on in Wyoming. We're citing this through the authority through Section 1222 of the Energy Policy Act of 2005, okay? Which, for those of you who don't remember everything in the Energy Policy Act of 2005, this is basically a provision that was modeled after Path 15. And Path 15 was a long-standing constraint in California that they just couldn't figure out how to get it done. There was language written into an appropriations bill, which basically gave Western Area Power Administration the authority to work with private developers who would go forth and finance this project. They would own the capacity rights, Western would own the project, and that project got built, and it's very successful, and it's part of the grid in California. So what happened was, building on that success, so as they move forward with EPACT 05, they said, okay, here's a way to get transmission built using federal authorities but private investment dollars. And so basically what Section 1222 does is it allows the Department of Energy to work through two PMAs, Western Area Power Administration and the Southwestern Power Administration, to site transmission lines in those states where they already have the ability to site lines. And so for our purposes, this is the states of Oklahoma, Kansas, Texas, Missouri, and Arkansas. And so we have an agreement with the Department of Energy. It's sort of a pre-development agreement where they take the role of NEPA lead agency We pay all their bills if they're traveling or doing anything else, or they dedicate time to it. We pay for all of this stuff. And they are leading us through the NEPA process, which is also important to us because we connect with TVA. So we're working closely with DOE and Southwestern Administration in a way somewhat similar to the way that the projects out west will work with the Western Area Power Administration. So just the quick numbers on this project. So it's we will gather up, there's many developers active in the Oklahoma Panhandle region, wind resources in the sort of 8.7 to 9.5 meters per second range. So with the new modern turbines, you're seeing capacity factors in the range of 50 to 55% with the new turbines. So extraordinarily good wind resources. It's a highly undifferentiated wind resource. So if you've been to the Oklahoma Panhandle, you probably noticed that it's really flat. That means that there's a lot of different places that you can build wind. There's lots of developers active in the area, basically because there have been a few AC upgrades taking place there, which you announce 500 megawatts of AC upgrades, and you will attract around 10,000 megawatts of new wind developers. So there's lots of folks active in the area. We believe that they'll do a really good job of building projects in this RFI that I mentioned a minute ago. We think is good evidence of that. So they will tie in to our DC converter station, and then we'll ship the energy east as far as the TVA system to a substation called Shelby, which is north of Memphis. And the TVA system is one of the best transmission systems in the country. It was built with a vision of around 20 nuclear power plants. Ultimately, around 10 will be connected to the TVA system, at least in the foreseeable future. And so that means there's a really robust grid. And from TVA, TVA is actually acquiring a fair amount of wind now. And it's also just one wheel away from Southern Company and other folks in the southeastern United States. So we have been at this one for about 4 years, and we've concluded the scoping process recently. We will be in the draft EIS early next year, and hopefully in a final EIS by the end of 2014. I think I already mentioned this, that we are, again, we're not doing the wind development, we're just doing the transmission piece of this. And that's a little bit different from some of the models that you've seen in Wyoming, which in Wyoming sort of makes more sense because you've got huge single owner tracts of land that you've got to be, you almost need to forward integrate if you want to get that wind to market. This is, as you can imagine, this is a lot of energy, 3,500 megawatts. I like to talk about this. This is roughly, the energy output of one of these projects is roughly equivalent to the annual output of 3 Hoover dams. So it's a lot of power. So we're going through all the exciting regulatory and interconnect things that not everybody finds exciting, but we find these things really exciting. So from a FERC perspective, we have to go out and negotiate with our customers. So you have to have a negotiated rate authority. I mentioned that the DOE agreements. We have become a public utility in Oklahoma. In Arkansas, it's a whole different set of issues. Arkansas really likes our project, but they can't fit it in their laws, thus the need to use 1222. We're going through the system impact studies at the TVA end, and this is always interesting because you show up and say, I remember our first meetings with TVA, there were 2 of us plus an intern in the company at the time, and we went to TVA and said, hey, we filed an interconnect for 3,500 megawatts, and they're like, okay, no, you guys? They're like, who's gonna do this? But that's the way you start anything, right? And so we've been working through the process with TVA. We have an MOU with them that not only are we doing the interconnect, but a bunch of other issues we're working through with them. At the weak side of the grid, or the windward side of the grid, and I'm sure this is issues that y'all deal with as well, This is a really important connection because the nature of DC technology is such that you need voltage support on the windward converter side. Southwestern Power Pool actually has a process that you go through called the Criteria 3.5. We've gone through that, everything's going fine. Learned a lot of interesting things. If you guys want to read any of these studies, you can download all of them on our website. Then we're going through the route network with DOE and so on. So we think that there's an important federal role for us, but there's also a huge role that we think it's incredibly important that we work as hard as we can to make sure that our project works well for the states where our project originates, where we deliver energy, and in this case Arkansas, the state that we pass through. So we do a lot of supply chain work. We have an agreement with Fluor as the EPC development partner, and Fluor runs with us supply chain open houses all along the route of the line so that we can identify and pre-qualify surveyors and excavation companies and aggregate suppliers and everybody else that might play a role in the project, so we have a big database of those folks. We also enter into formal agreements as we pre-qualify folks like General Cable, who will supply the conductor for this project. They have a plant in Arkansas. There's a company called Pelco Structural, which builds monopole towers. They're located outside Tulsa. We have a supply agreement with them. And we think that by formalizing these supply chain arrangements, we'll be able to build support for the project along the route. And then we do sometimes I mentioned sometimes we think that we're a think tank. We also sometimes think that we are a public outreach company, and that's where we dedicate at least half of our organizational energy. So in 2012, we did 20 open houses, 33 roundtables, business opportunity meetings, and that's all before we did the scoping process. So as y'all know, you go through a lot of processes along the way here. We anticipate, we're on a schedule such that we'll get a draft EIS out early next year and then so on, and hope to be in construction in the 2015 timeframe. We are cheering as loudly as we can it feels like Transwest Express is a little bit ahead of the ATC Duke folks, whom we also cheer on, but we really hope that Transwest Express is successful as soon as possible, because we feel like if one of these projects goes, it's really going to beget success in terms of getting other projects underway. So you guys know, I won't bore you through all the process that you go through, an iteration of different route development, but we strongly believe that there's nothing like shoe leather and one-on-one conversations to build support for your project. And we spend a huge amount of time, and we try to make sure that we track all these conversations. We make sure that we've recorded any commitments that we make, that we know exactly who we need to talk to, and that ranges from early discussions with county commissioners. As soon as landowners hear of a project like this, they're going to call the elected official they know, and that's the county commissioner. So we want to get in and talk to a county commissioner early on and tell them where we're coming from. And this is sort of coming back to the view that these answers may not come from Washington. We're big into sort of ground up development. So start at as local a level as you possibly can, and then sort of work your way up to the state level, and then ultimately Washington to the extent that they're involved.